Hello guys, hope you are doing well. In today's video, I'll be talking about the complementary part of the Section 2, and then I'll be talking about the Section 3, Chapter 2 as well. Guys, in the previous session, we talked about the Lewis's definitions with the Bronsted-Lowry as well. If you remember, we said the Bronsted-Lowry acid-base definition depends on the donation and acceptance of proton, and the Lewis's definition depends on the donation and acceptance of pair of electron to form covalent bonds. And then we said the Lewis acid-base reaction is a reaction usually we have got in the reaction the acids plus the bases, acids plus the bases that form a compound which is usually a complex compound that has a charge of positive or can be negative charge as well. So the structure of Lewis's reaction is different than the Bronsted-Lowry in that in Bronsted-Lowry there should be two reactants and two products. But here in Lewis always follows in this structure of having two reactants and one product, and that product is a complex compound which has a charge can be positive and negative as well, but usually it's negative. Guys, that was about the structure of the Lewis's acid-base reactions. Let us talk about some of the reactions which there are species that can give us all the definition or meet the conditions of all the definitions. Here we have got an example. Let us talk about that example. H2O plus ammonia formed ammonium and hydroxide in the solution, guys. Let us talk about the H2O first. H2O in this case donates a proton. So according to the Arrhenius, H2O is a solvent only. It's neither a base nor an acid. But according to the Bronsted-Lowry donated a proton, it becomes a Bronsted-Lowry acid. According to Lewis, H2O is base. But we said previously, whenever a compound or an ion or a molecule donates a proton, cannot be classified as Lewis. So it's not a Lewis base or not a Lewis acid. But let us talk about the ammonia. Ammonia in this case, guys, increases the hydroxide concentration, so it is Arrhenius base. First. Second, for the Bronsted-Lowry, accepts a proton, so it's a Bronsted-Lowry base as well. For the Lewis, you can notice the pair of electrons donated to that proton, which accepted by the ammonia, so it's a Lewis base as well, because any molecule or species that accepts a pair of electrons, it becomes a Lewis base. And if you remember, we said any molecule or ion that accepts a proton must donate a pair of electrons to that proton, because a pair of proton has no electrons. It only needs electron from the other species. So all of the Bronsted-Lowry bases are Lewis bases, but all of the Lewis bases are not Bronsted-Lowry bases. In terms of question, the question if asked about the reaction is Bronsted-Lowry acid-base reaction, because we have got two reactants and two products. Have a look on this, guys. NaOH, it's a metal hydroxide, cannot be classified as the Bronsted-Lowry and also cannot be classified as the Lewis as well, because there is no donation or acceptance of pair of electron, so it's only Arrhenius base. And according to the other examples, guys, HNO3 increases the hydronium, so it's Arrhenius acid and donates a proton to H2O, so it is a Bronsted-Lowry acid. But is that a Lewis acid? No, because it donates a proton. But H2O, guys, in this case, H2O accepts a proton, so it's a Bronsted-Lowry base. And when it accepts a proton, donates a pair of electrons to that proton, so it's Lewis base as well. And in terms of the reaction, it's a Bronsted-Lowry acid-base reaction. Have a look on the other example, guys. H positive, we have got H positive in this example. The H positive accepts a pair of electrons from the ammonia, so it's only Lewis acid. We cannot say it's Arrhenius or Bronsted-Lowry. Why? Because Bronsted-Lowry must donate a proton in order to be the acid. There is no. So guys, the ammonia donates a pair of electrons, it becomes a Lewis base, and also accepts a proton, it becomes a Bronsted-Lowry base. In terms of the reaction, guys, the reaction is the Lewis acid-base reaction. Why? Because we have got two reactants and one product, which is a complex compound. What's the reminder for this section, guys, is this table. You have just to be careful about the terms of acceptance and donation in between Lewis and Bronsted-Lowry. Guys, the Bronsted-Lowry acid is a donor of proton, so is a donor. But according to the Lewis, it's the acceptor. So here, Bronsted-Lowry donor of a proton, but here acceptor of a pair of electrons. So do not be confused about the terms. But bases, it's an acceptor according to Bronsted-Lowry, but it's a donor according to the Lewis. But here accepts a proton, they donates a pair of electrons. And that's the all about the acids and bases. Here we have got some ministry. Guys, let us practice some ministry exam question in section 2. The first one states that is an atom, ion or molecule that's an electron pair donor. Of course, the Lewis base is the pair donor of electron. B is the correct answer. Which reactant in the reaction below acts as a proton donor or proton acceptor as acid or base? Of course, carbonic acid is acid and the H2O is the base. H2CO3 acid and proton acceptor? No, it's incorrect. Base and proton donor is incorrect as well, H2O. H2CO3 is acid, yes, and proton donor, yes, C is the correct answer. The following reaction, choose the correct answer. This reaction, we have got two reactants and two products, so it's a Bronsted acid-base reaction. Let us solve much more questions, guys. The question 4 said dilute aqueous solution of weak acid, of course, contains hydronium, the anion, and the weak acid as well. So all mentioned both is the correct answer. When ammonia forms a covalent bond, the covalent bond refers to the Lewis's definition, guys. So when it refers to the Lewis's definition, ammonia becomes a Lewis base. Which of the following definition of acids and bases related to the proton effect? Of course, Bronsted-Lowry relates to the proton effect or the effect of the proton. Much more questions. In the following reaction, H2O acts as what? Guys, H2O here donates a proton. When it donates a proton, it only acts as what? As the Bronsted-Lowry acid. This equation, two reactants and one product which has a sign, a complex, is a Lewis acid-base equation. A molecule or an ion that's a proton acceptor. A proton acceptor is what? Is a Bronsted-Lowry base. Is a Bronsted-Lowry base. When ammonia forms covalent bond and behaves as, this is second time appearing ministerial exam question. Twice appears in ministerial. The given equation, which is given, represents what? This equation, two reactant and one product, it represents a Lewis acid-base reaction, guys. And we have to talk about the section 3, which is all about the acids and base conjugates. The conjugates, we mean the friends. Okay, guys. Previously, we talked about the definitions of the acids and bases. We have defined the acids and bases based on three definitions: Arrhenius, Bronsted, Lowry, and Lewis. But guys, in this section, we specify the topic based on the Bronsted-Lowry definitions, because the term of conjugates refers to the product sides and can be reactant as well. We'll be talking about that. But which of those definitions defined the conjugates? It was Bronsted-Lowry. So in this section, we will talk about the Bronsted-Lowry definitions for the term of conjugates, and the conjugates based on the definition of Bronsted-Lowry. A conjugate acid and a base, guys, we simply can differentiate between a conjugate acid and a base, a species that is formed when a Bronsted-Lowry base gains a proton. So a base gain a proton, what will be formed? A conjugate acid. A conjugate acid. Or simply, guys, in a form of an equation, what we can say the bases plus a proton. A base plus a proton means accepts a proton is the conjugate acid. How about conjugate base? Conjugate base is an acid minus a proton. A species that remains after a Bronsted-Lowry acid has given up a proton is a conjugate base. Or we can say simply acid is minus a proton. Acid minus a proton, remove a proton from the acid, you'll get the conjugate base. The Bronsted-Lowry acid-base reaction involves two acids and two acid-base pairs. These pairs recovers the conjugate acid-base pairs. Which species they become acid-base conjugates? Guys. An acid, here I have stated, an acid can be a conjugate pair. With what? With a conjugate base. So what can be conjugate pairs? Acid with its conjugate base are the conjugate pairs. Base with its conjugate acid can be the pair, but with meeting one condition, which is what? In between them there should be one proton in difference. One proton in difference. Let us determine the conjugates and the conjugate pairs in this example, guys. Here HF donates a proton to H2O to form hydronium and F negative. HF is acid, H2O becomes a base. So guys, a conjugate acid is what? Whenever this base accepts a proton, what format in the product? Hydronium. So the hydronium is a conjugate acid. But when the acid donates a proton, what's the remainder? F negative, which becomes a conjugate base. And guys, in this reaction, and from several other reactions, usually it's not always, we can say the cation is the conjugate acid and the anion is the conjugate base, usually, but we have exceptionals. What can be conjugate pairs? In every acid-base Bronsted-Lowry reaction, there should be two conjugate pairs. The acid with the conjugate base are the pair of each other. The base with the conjugate acid are the pair of each other. As you can see, guys, HF and F negative, they have one proton in difference. H, F, F negative. The same for H2O and hydronium. They have one difference in protons. That's why they can be conjugate pair of each other. H2O is base and hydronium is a conjugate acid and of H2O. Therefore, H2O and hydronium are conjugate acid base pair and their difference is 1 proton. In general, guys, the Brunsch-Berry acid-base reaction are equilibrium systems, means there are reversible processes that both the forward and reverse reaction occur. They involve two acid-base pairs known as conjugate acid-base pairs. In every conjugate acid-base pair, the acid has one more proton than its conjugate base. This is another technique to recognize the conjugates. The acid has one more proton than the conjugate base. And the base in the reactant has one less proton than the conjugate acid. Have a look on this example, guys. For example, H2PO4 negative with H2O form hydronium and HPO4 negative 2. This is acid and this is base. A conjugate base, when accepts a proton, becomes what? A conjugate acid. And then this donates a proton, the remainder becomes a conjugate base. This acid with the conjugate base are pairs. The base, H2O with the hydronium, are pairs of each other. So these two are given. Here are two acid-base pairs in this reaction. The same for the ammonia and H2O. The ammonia is the base, H2O is the acid. Ammonium is a conjugate acid of the ammonia, and then hydroxide is a conjugate base of H2O. The base with the conjugate the base with the conjugate acid as conjugate pairs. The acid with the conjugate base are a pair of each other, guys. Strength of conjugate acids and bases. We talked about the strength of acids and bases in the previous sessions. Let us talk about the strength of the conjugates. Guys, there is a tip to determine the strength of the conjugates. The tip is that the strength of the conjugate, we are taking their strength from the acids and bases. As the acids and bases are strong, they will produce a weaker conjugates. As the acids and bases are weak, they will produce stronger conjugates. So we can say simply the conjugate strength is just the opposite of the acids and bases. Acids and bases. Have a look on this example, guys. HCl is what? HCl is a strong acid. Is what? Is a strong acid. How about H2O? Let me tell you how to determine the strength of H2O, guys. If a strong acid combines with H2O, in this case always H2O becomes a strong base. The strength of the H2O varied according to what it reacts with. If the chemical is a strong acid, lets the H2O to be a strong base. If the chemical is the weak acid, lets the H2O becomes a weak base. If the chemical is weak base, lets the H2O to become a weak acid. So the strength of H2O depends on the strength of the chemical which reacts, acids and bases which react with H2O. Weak acid with H2O, H2O becomes a what? Weak base. If weak base reacts with H2O, H2O becomes a what? A weak acid. And in some exceptional cases, there will be strong acids react with H2O, like the hydride we'll be talking about. Hydride, calcium hydride, we have an example. When the hydride reacts with the H2O in that case only is somehow exceptional case that acts as what? As the strong acid with the strong base hydride which comes. So in this case, guys, the H2O is a strong base. Why? Because it comes with a strong acid. What will happen to the conjugates? The weaker conjugate acid and weaker conjugate base will be formed. Why? Because the acids and the bases are strongest here. So the stronger an acid is, the weaker its conjugate base. The stronger a base is, the weaker its conjugate acid. That's simply the conjugate strength, or the strength of the conjugates. Guys, HClO4, the same, is a strong acid. So H2O becomes a what? A strong base. Hydronium, weak conjugate acid. Chlorate, weak conjugate base. There will be a question that talks about the direction of proton transfer. Keep in mind, guys, always the direction of proton transfer is toward the weaker side. Is toward what? Is toward the weaker side. Stronger side to a weaker side, and product side is more favorable in this above reaction. The reaction to the right is more favorable. For strong acids, this is a technique, this is a tip, a note. For the strong acids and bases, always forward is favorite, and for the weak acids and weak bases, always reverse is favorite. Why? For the strong acids and strong bases, they are strong, they will produce weaker conjugates. That's why the forward is favorite toward the weaker side. But for the weaks, they are weak, they will produce stronger conjugates. We'll be talking about the examples about the weak. So the reverse is favorite toward the weaker side. Guys, for the strong bases like metal hydroxide, you know that the metal hydroxide, they are not Bronsted-Lowry bases. So if something is not a Bronsted-Lowry basis, and the term that conjugate is based on the Bronsted definition, they do not have conjugates. So the metal hydroxides, they do not have conjugates. Have a look on this weak, guys. This is weak. The weak acid, so water becomes what? Weak base, depends on what it can react as well. A stronger conjugate acid, a stronger conjugate base. So the proton direction is toward the reactant side because it's weak. Strength of water, guys, I told you, the strength of water depends on what the substance which reacted with. If it reacts with a strong acid, it becomes a strong base. If it reacts with a weak acid, it becomes a weak base. If it reacts with a weak base, it behaves a weak acid. For this table, what we have to know about this table, guys? This table is a table which is table 6 in our book. We have to know somehow 3 types of informations. The first one, the top and the bottom, in terms of what? The strongest acid in the table is what? Is HI. And will produce when it donates a proton, a weakest conjugate base. A weakest conjugate base. So HI is what? Is strongest acid will produce a weakest conjugate base. We have to know that HI is strongest acid and then produce the weakest conjugate base, which is I negative. The same for here, H2 is strong weakest acid will produce what? Hydride, which is negative, is strongest base, strongest conjugate base. H2, H negative. How it becomes H negative? By what? By gaining an electron. By gaining an electron. Because guys, we have 3 forms of H. H itself, 1 electron and 1 proton. H positive only one proton without electron, H negative, one proton but two electrons. Gain it another electron. So this is hydride, this is proton, and this is the hydrogen neutral atom. The hydride is the strongest conjugate base of the hydrogen gas. So a strongest acid has a weakest conjugate base of Hi. H2 is the weakest acid. Hydronium, and the second information which we have to know, we talked about previously, but hydronium is, let me show you on the table, guys. Hydronium, the position of hydronium here, below the hydronium, all the acids becomes weak, and the above hydronium, all the acids are strong. How about hydronium? If we compare hydronium with the weak, is the strongest among all the weaks. If we compare with the strongest, it behaves as the weakest among all those strongest. The third information, guys, for the binary acids, strength of the binary acids, Hi is the strongest, then HBr, HCl, HF, and H2S. This is what a strength of the binary acid, which should be known. And in general, you have to know that a stronger acids and base produce weaker conjugates. This table is to prove that to us. We have amphoterics, guys, amphoteric compounds. In the branch theory, in the second section, we talked about the property of H2O, which acts as amphoteric. Today we will be talking in detail what's amphoteric and what type of amphoterics do we have. Guys, usually, the definition of amphoteric is that any species can be neutral ion that has tendency to deal as both Bronsted acid and Bronsted base, can donate proton and accept proton as well, but not at the same time, in two different mediums and reactions. The amphoterics, we have neutral compounds for amphoteric, guys, neutral compounds and ions. So we have two types of amphoterics. The neutral compounds in our book are 4 neutral compounds: H2O, ammonia, which are the most frequently used two amphoterics, with the chromium 3 hydroxide and aluminum 3 hydroxide, or aluminum hydroxide and chromium hydroxide. So these are the only 4 compounds, neutral compounds, which can behave as amphoteric. How about the ions? For the ions, there is a tip: any ion that has tendency to donate a proton and accept a proton, or the ions that remain from the diprotic and triprotic acids, they usually behave as what? As the amphoteric ions. But except was, guys, here we have got hydroxide and hydronium. They are not amphoteric ions. Hydroxide is only a base, hydronium is only an acid. Example for the amphoteric neutrals, have a look on NH3. NH3 in this case accepts a proton, so it behaves as a base to form ammonium and hydroxide. But in the second one, NH3 donates a proton to the hydride, so it acts as an acid, and then to form amide with the H2. For the amphoteric ions, guys, H2PO4 negative with H2O produces hydronium and SPO4, so it donates a proton, that's why it becomes an acid, and H3PO4 plus H2O formed hydronium and H2PO4 negative 1, H2PO4 negative 1 is the base or conjugate base of that acid which is given. There will be a type of question, the ion is given, for example, HS negative or HSO4 negative. What's the conjugate acid of that, conjugate base of that? Guys, for the conjugate acid and the conjugate base, always the species, when you add a proton to it, you get a conjugate acid. When you remove one proton from it, you get a conjugate base. So plus a proton, a conjugate acid, which is H2S, equals a conjugate acid. Minus a proton, you get a conjugate, S2 negative, a conjugate base. The same here, guys. Plus a proton, you get H2SO4, which is a conjugate acid. Minus a proton, we'll get SO4 two negatives, which is a conjugate base. So whenever asked about conjugate acid of something, just add a proton to that. Conjugate base of a species, just remove a proton from it. That's about the conjugate acids and the conjugate bases. Guys, can a conjugate be in the reactant? Yes, it can be in the reactant. So if you take, usually for reversible reactions like this, both the reactants and product can be conjugate of each other. Guys, suppose this is a base and this is the acid. If this acid donate a proton, what will be the remainder? A conjugate base. So H2O can be a conjugate base. And if a base accepts a proton, what will be formed? A conjugate acid. So S3PO4 is a conjugate acid. It appears in ministerial exam question that which of the following is the conjugate acid of a base in the list. The list, it was S3PO4, H2O, H2PO4 negative and PO4 negative 3. So the question, the answer, it was S3PO4, which is a conjugate acid of a base in the list, which among the options which is given. So guys, simple. The reactants, they have the conditions of conjugates. They can be conjugates of the products, but this usually happen for those that are weak and reversible. We have got the reaction of metal hydrides with the H2O. Guys, whenever a metal hydride reacts with the H2O, the product is a metal hydroxide with the hydrogen gas, releasing metal hydroxide and hydrogen gas. Here we have got an example, but there are several examples. Can be, instead of calcium, can be magnesium, lithium, cesium, barium, and so many other examples. So in this case, it's always, guys, if you know one, this can be applied for all the hydrides, the metal hydrides. When a calcium hydride reacts with H2O, calcium hydroxide formed with the hydrogen gas. This is the general form. Write the overall equation. This can be somehow dissociates into Ca positive 2 and H negative, and H2O stay unchanged. Calcium hydroxide dissociated into calcium positive 2 and hydroxide, and then with a hydrogen. As you can see that the Ca becomes what? The spectator ions. Spectator is the Ca. What's the remainder here? The H negative plus H2O will produce hydroxide plus H2. Guys, the H negative, which is the hydride, is a strong base. And then this was the case I told you previously. The H2 in this case becomes a strong acid. What will happen to the product is it's the weak conjugate base, and H2 is a weak conjugate acid. Always that's the case for the hydrides, metal hydrides. Let us talk about the hydroxide in compounds, guys. The hydroxyl group in compounds, The hydroxyl group, unlike the hydroxide, they exist in molecular compounds. The structure is OH in compounds. This can be confused with the OH negative, which is hydroxide. We will be talking about the differences. Guys, OH group, if it exists in any compound, this group we call as the hydroxyl group. This is the hydroxyl group. It contains in only a molecular compounds. So, hydroxide is in the ionic compounds, but hydroxyl group is in the molecular compounds. If it exists in a molecular compound, what will happen to the molecular compounds? The molecular compounds exist in two types. It can be acid only or amphoteric. Acid only or amphoteric. Acid is like the oxyacids, amphoteric ions connected to the hydroxyl group. Example, guys, let me provide two examples. For example, H2SO4. If you open the structure, it's connected with 4 oxygens, and 2 of the oxygens they connected with the hydrogen. So these OHs are the hydroxyl group. It has got 2 hydroxyl groups and it's an acid. Example for the base, or not base, the amphoteric. HSO4 negative. Is that amphoteric? Yes, it has tendency to donate the proton and accept another proton as well. So guys, this is the structure. It's connected or bonded with the 4 oxygens and one of the, of course, with the negative, and one of the oxygen with the hydrogen. This is one of the hydroxyl group. This is hydroxyl group, and this is amphoteric as well. So it can be amphoteric, the hydroxyl group containing compounds, and the acids as well. Guys, the behavior of the compounds affects by the number of oxygen. Whenever the number of the oxygen increase, in this direction the number of the oxygen increase, what will happen to the property of the compound? It becomes more acidic. You can determine from this example, chromium 2 hydroxide is basic, which has got 2 oxygen. Chromium 3 hydroxide is amphoteric, which is 3 oxygen. And chromic acid has got 4 oxygens, which is acidic. So acidity increase as the oxygen number increase. And here we talk, previously in the strength of the acids, we talked about the electron density. We said as the electron density increase, the polarity decrease, and then acid strength decrease as well. So what's the relation between electron density and the strength of the acid? Is inversely proportional. Or we can say, as the number of the oxygen increase in this direction, what happens to the electron density? Decrease. So as oxygen increase, the electron density, what we mean by the electron density? The electron density in the bond between the OH, the hydroxyl groups, that will reduce, and having more oxygens around the central atom will reduce the density of electrons in the bond, and then the bond becomes more polar, and then it becomes more acidic. The difference between hydroxide and hydroxyl is that, guys, hydroxide refers to a charged polyatomic ion, which is OH negative, and it's combined with the positive ions in ionic compounds. So it's a charged polyatomic ion combined with positive ions in an ionic compound. But hydroxyl group is OH, is covalently bonded to the other central atoms, often carbon, such as C2H5OH, which is ethanol, and the hydroxyl group is existing in the molecular compound, is not in the ionic compounds. Here we have a question said CH3COOH with the ethanol, which is C2H5OH, they have the same structure of their composition, they have the same elements. But why we call acetic acid as acid, not ethanol as acid? This is because of having one more oxygen in the acetic acid, which increases the polarity of the bond between OH, but not having that oxygen. Instead of the oxygen here we have got hydrogen. The polarity of this bond is not as the above, because the oxygen there increased the polarity. That's why it increased the tendency of acetic acid to donate or release protons much easier than the ethanol. But guys, the alcohols, because of they do have the hydroxyl group, they have a tendency to be an extremely weak acids. So they are, ethanol is essentially neutral. It has no second oxygen atom, so the OH bond is less polar than in acetic acid and is much weaker acid. So when it said much weaker acid is in the figure, that means it can be classified as the weak acids, very weak acids. As the number of the oxygen atom increases, the acidity of the compound increases as well. We'll be talking about neutralization reaction. What's a neutralization? What it can be used for? So let us talk about that. Guys, neutralization reaction in our daily life, there are several reactions, but simply we mean whenever an acid reacts with the base, the acid is going to produce hydronium, the base hydroxide, they neutralize each other to form H2O. Have a look on this example, guys. Sodium bicarbonate is given here, reacts with the tartaric acid, produces a salt and H2O. This is a neutralization between tartaric acid and sodium bicarbonate. Another example, guys, of course with the CO2, because whenever the sodium bicarbonate or carbonates reacts with an acid, they will produce CO2, H2O and a salt as well. HCl here, guys, HCl, which is an acid, reacts with the sodium bicarbonate, formed NaCl, H2O and CO2. So the product produces the salt, H2O and CO2. This is only for the carbonates when they react with the acids. Guys, this is a neutralization reaction, but it's between what and what? In between 2 weeks, a weak acid with a weak base, or it can be between a strong and a weak. But in our book, concentrated much on the neutralization between strongest. Let us talk about the neutralization of the strong acid and strong bases. Simply, the term of neutralization refers to what? The reaction of the hydronium ion from the acids and the hydroxide ion from the bases to form H2O, to form water molecule, In this part, guys, the salt is mentioned. So I will be explaining the types of the salts and providing examples. You'll be prepared for the chapter 6 as well, because we'll be talking about the types of salts in chapter 6. We have got 4 types of salts, guys. The acidic, basic, neutral, and the salt is a combination of 2 weeks, which can be both acidic, basic, and as well neutral. But simply, salt is what? Is an ionic compound. Ionic compound. Formed from what? From cations of a base and an ion of an acid. cation of a base and an ion of an acid. So that, guys, I will be providing acids, bases, salt. An acid, HCl, a base, NaOH. An acid, HF, a base, KOH. An acid, HNO3, a base, NH3. An acid, HCN, a base, NH3. They will produce 4 salts, and for each of them there will be a different type. Guys, the anion of a base with the cation of an acid, NaCl. Okay, NaCl. And then let me use the black. Okay, K with the F, KF. NH3, it becomes NH4 plus NO3, it will be NH4 NO3. And then the NH3 with the CN, it will be NH4, sorry, CN. Guys, the first one is a neutral salt. Why? A neutral salt is one that the cation from a strong base and an ion from a strong acid. Whenever the acids and bases, they both are strongest, they will produce a neutral salt. But if one of them is strong, they will produce the salt of the strong. Which we mean here the base is strong, the acid is weak, so it will produce a basic salt. This is a basic salt. The other is a neutral salt. HNO3 a strong acid, ammonia a weak base. So which one will be the salt? The salt of the acid, the strong. It will be a acidic salt, this ammonium nitrate. How about HCN with the ammonia? HCN and ammonia, they will produce a salt which comes from 2 weeks. If it comes from 2 weeks, guys, they're both cation and an ion, can be acidic, basic, or neutral. It depends on what? It depends on the Ka and Kb values. If Ka equals Kb, that means it's neutral. If Ka, which constant ionization of acid, Kb is constant ionization of base, is higher than the Kb, is acidic, the salt becomes acidic. If Kb, constant ionization of base, is higher than the constant ionization of acid, it becomes a basic. An example for this type of salt is NH4Cl. So, acidic salt is a salt from a strong acid and a weak base. Basic salt from a strong base and a weak acid. Neutral from 2 strongest, the last from 2 weaks, which can be neutral, acid, and base. Guys, we have this neutralization reaction between HCl and NaOH. They produce a salt and H2O. In order to write the net ionic equation, we have to write the overall. So the Na and Cl, they cancel it because they are spectator. What's the remainder? The remainder is hydronium plus hydroxide form 2H2O, and this is the neutralization reaction for the process. Keep in mind, guys, a note. There were a Ministry of Exam question we'll be solving later. This equation is the net ionic equation of a strong acid plus a strong base, which they produce a soluble salt. So whenever a strong acid neutralizes it with a strong base, they produce a soluble salt, of course, plus H2O. But we do not mention the H2O because we are talking about the salt only. The condition is that the soluble salt, always the net equation becomes that equation. Hydronium plus hydroxide to form H2O. Let us solve for some of these questions which given in the chapter review. Here the metals reacts with the acids. You know that, guys, when the metal reacts with the acid, you get what? The salt and the hydrogen released. And then write the overall equation. Then this becomes hydronium, 2 hydronium plus 2Cl will produce ZnCl and then hydrogen and 2H2O. Why we add 2H2O? Guys, here we have got 2 proton. So 2 proton combines with 2H2O to produce 2 hydronium. In order to form 2 hydronium, we added 2H2O for the reactant. So the same amount of the H2O must be added to the product. That's why we added H2O to the product. In the above, in this equation, Cl negative is the what? Is a spectator ion. The remainder becomes the net ionic equation. The same for the aluminum and sulfuric acid, guys. Here we have aluminum, 6 hydronium. Why? Because 6 proton. In order to be 6 hydronium, it needs 6 water. That's why we added 6 H2O to the product as well. The sulfate is what? Is a spectator, and the remainder is what? Is the net ionic equation. I have explained this. Every proton to form hydronium reacts with water. Any hydronium exists in the reactant, the same number of water, molecules must be added to the product to balance the reaction. So we added water to balance the reaction. We have a note here, guys, prior to the acid rain. The note states what? Said if a soluble salt in the result, which I talked about, in the result of a neutralization, always the net equation is hydronium plus hydroxide to form H2O, and an example, nitric acid and NaOH is given. But if an insoluble salt formed, the result of a neutralization reaction, the net equation equals to the overall ionic equation. In this case, the net becomes the overall. Example, for example, barium hydroxide with sulfuric acid produces barium sulfate, which is insoluble, and H2O. It's a precipitate. In this case, the whole overall equation becomes the net ionic equation. You have to be careful about this case. Acid rain, guys. Acid rain, as a definition, let us define the acid rain, is a type of a precipitation, can be rain, snow, or any other types, that contains a high concentration of hydronium due to the presence of pollutants, the gases pollutant. So the acid rain, what's important in acid rain? The 5 gases in our book which they produce acid rain: nitrogen monoxide, nitrogen dioxide, carbon dioxide, sulfur dioxide, and sulfur trioxide. Those gases are responsible to form acid rain. How? The gases, they are going to react with H2O to form an acidic solution. H2O to form an acidic solution. H2O to form an acidic solution. So these gases, due to the emissions of industrial processes, the gases, they mix with the cloud in the atmosphere, and then when the water condenses, they will react with the droplets of water, and then they will produce an acidic precipitate. The effects of rain, acid rain is what? Rainwater is normally acidic, somehow is acidic, but its acidity increases and becomes acidic when but sometimes rain is very acidic and is called acidic rain. When the acidic gases or the pollutant gases react with H2O. It has effects on the lands and environments in general, erodes structures, and affect ecosystems such as water, environment, and forests. It can burn the forests, the lands, and so as well it can increase the acidity of the water environment. Acid rain was causing the fish population in some lakes and streams to decline. It reduced the population of the fishes in the lakes because of the fishes that are not able to live in a high acidity medium or a low pH medium. When fish are completely eliminated from lakes and streams because of acid rain, the biodiversity of the ecosystem decreases. So it affects on the ecosystem, affects on the lands and the lakes as well. Here we have got the ministerial exam question, guys. Let us practice some of the exam questions. Which one below is formula equation given? The formula equation, you have to complete the reaction. So it will be calcium hydroxide with the HNO3 will be calcium nitrate, CaNO3 by 2, which is soluble with the H2O. So the first one says insoluble. That's not correct because calcium nitrate is soluble. The second one said aqueous and H2O, so the second one is the correct answer. But the third said CaNO3 not by 2, and the fourth CaNO3 not by 2 and solid also. So B is the correct answer. Which one below is not ionic equation given a reaction? So it's a strong acid with a strong base. They will produce strontium chloride. Strontium chloride is soluble. So hydronium plus hydroxide to form H2O. Hydronium plus hydroxide to form H2O. Which one below is formula equation given reaction? Aluminum with the sulfuric acid. We solved it above, guys. The aluminum, this will produce 6 hydronium in the reactant, and then in the product 6 H2O must be added. So the formula equation is given, but the net is not. The formula equation is the requirement. The net is not the requirement. So you form aluminum Al2SO4 by 3, and then H2 gas. That will be the aluminum sulfate, which is a soluble salt, and the plus H2 gas. So which one is true? Of course, the balanced equation is B. B is the balanced equation, which is the number of the aluminum and hydrogen balanced. But in the question for the ministerial exam said, which one is net of this reaction? Of course, the net should be the 6 hydronium. We solve it. 6 hydronium with 2 aluminum formed 2 aluminum with 3 hydrogen and 6 H2O. C is the correct answer because this is the correct balanced net equation. What's the formula of chloric acid? Easy question. A chloric acid has a formula of what? Of HClO3. D is the correct answer. The reaction of this reaction shown the net equation for what? As I told you, this is a ministerial exam question. So try to find a strong acid with a strong base that form a soluble salt. NaOH with HNO3, this is the correct answer, which they form a soluble salt. An ion of a salt is formed from the combination of weak acid and strong base. Strong base, for example, KOH, and weak acid HF, this will produce KF. An ion of a salt, the anion, we are talking about the anion, acts as what? This F comes from HF. HF is a weak acid. So F negative, if we dissociate, it becomes a strong conjugate base. So conjugate acid, no, conjugate base of a weak acid, yes, that's the correct answer. Label one of the conjugate base pair for this reaction, guys. The conjugate base pair, this is the accepts a proton, so it's a base, and this one acid, a conjugate acid, and a conjugate base. So Cn and hydronium, they are not conjugate pairs. because they exist in both, both in the reactant, one must be in the reactant, the other in the product. HCN and H2O still also, again, they are not the conjugate pairs. Why? Because they exist in product both. HCN and hydronium, HCN is acid and hydronium is acid. They are not conjugate acid-base pairs. HCN and CN negative, HCN is conjugate acid and the CN is base, so this is the correct answer. According to Branch-Lowry theory, conjugate base is required. Conjugate base, that means remove a proton. Remove a proton. So you get what? HISO4 two negatives. HISO4 two negatives. Which one? HISO4 two negatives. A is the correct answer. What's the reason that the presence of several oxygen atoms in a compound containing hydroxyl group can make the compound acidic? The oxygen makes the OH group most polar? Yes. H become less ionized? No. Electron density attract the OH bond? None of the above. A is the correct answer because oxygen makes the bond more polar. Why acidity of HClO3 less than the HClO4? Guys, because acidity increase, number of oxygen increase? Yes. Because hydrogen bonded with different oxygen? No. Because hydrogen bond with chlorine? No. All of the above. A is the correct answer. Which of the following is a conjugate acid of a base in the list? This is the question in ministerial exam. This, which is S3PO4, is a conjugate acid of a base in the among the options. Which of the following is amphoteric substance? Amphoteric substance, of course, D is the correct answer, which is HSO4 negative. The conjugate acid of this ion. Conjugate acid, that means add a proton. So when you add a proton, H2SO4 will be the conjugate acid of that. C is the correct answer. That's all about the chapter 3, guys. Let us solve just the standardized test prep. Okay. Let us solve the standardized test prep quickly, as quick as possible, and then we'll end the session. Which of the following is not the characteristics of an acid? An acid changes the color of an acid. Indicator is a characteristics. An acid has a beta test? No, so B is the correct answer. When an acid reacts with an active metal, the hydronium ion concentration increases. The metal forms anions. Hydrogen gas produced. C is the correct answer. Which of the following is a Branch-Lowry base? Branch-Lowry base. A proton acceptor. An electron pair, a proton acceptor. D is the correct answer. Which of the following is the most commonly produced industrial chemical, guys? Of course, this is the most industrial chemical. Sulfuric acid is the correct answer, which is D. Which of the following is the conjugate pair? Is a conjugate pair. H positive with the hydroxide? No. NH2 negative with NH4 positive, two differences. HCl with Cl negative, yes, these are the conjugate pairs. The sixth one, guys, what's the formula for acetic acid? A is the correct answer. 7, which of the following species is the conjugate acid of another species in this list? It was the ministerial exam question, which is B is the correct answer. And the question number 8, identify the salt that form when a solution of H2SO4 and CaOH by 2. They are both strongest, so the salt will become a neutral, and then it becomes a CaSO4, which is calcium sulfate, and the answer is A. Which of the following statement is true for the reaction below? The reaction is hydrofluoric acid with the hydrogen phosphate reacts to form fluoride and dihydrogen phosphate. The reaction said HF is the base. No. HPO4 negative 2 is the acid? No. F negative is the conjugate base? Yes. H2PO4 negative is the conjugate base? No, of course. That's the standardized test prep. And we have